Hello everyone, this is Dr. CJ Tak and today we will discuss about the approaches for the formulation of suspension in the chapter Coarse Dispersion in the subject Physical Pharmaceutics 2. So, here first one, if we want to prepare flocculated suspension or deflocculated suspension, we need to understand the different approaches that is used to formulate the suspension. So first of all, if we have the particles, that means we have one of the solute molecule we have to prepare the suspension. So over here in these particles, we need to add first thing that is required to prepare the suspension, that is the addition of wetting agent and dispersion medium. That means we need to use one of the solvent, and to make our particle wet, we need to use the wetting agent. Then afterwards, the three different approaches are there. First one, the incorporation of the structured vehicle. If we are using the structured vehicle, then the product that will be with us, that is the deflocculated suspension in a structured vehicle, it is a final product. Then if we are using addition of the flocculating agent, if we are using flocculating agent, then we could have the flocculated suspension as a final product. And the third one approach is that we have, that is the combination of A and B. That is, first one, we need to prepare the flocculated suspension. That means over here, first one we can say, we can do addition of the flocculating agent. So we could have the flocculated suspension, and then afterwards incorporation of the structured vehicle. Then we could have the flocculated suspension in a structured vehicle as a final product. So we will see this all the approaches one by one. So first one, if we want to prepare the dispersion of solid, first thing we need to prepare, that is the dispersion of the solid. So over here, dispersion of solid, it involves intimate contact of the solid with the water as a vehicle. See, first we could have the solid particle, we have the solid particle in a powder form, so we need to add them into the vehicle, and as a vehicle we are using the water. So that first thing that involves in our formulation of the suspension, that it involves intimate contact. That means the contact should be produced in between the solids and water. So most of the solid, if we are considering, then they are hydrophobic in nature. So always they are difficult to wet, or we can say they are difficult to mix with the water. So in case of suspension preparation, what we are doing exactly, when we are preparing any formulation suspension, so at that time we have the raw material, we are converting them into finely divided particles. That means we are going for the size reduction process. So afterwards the size reduction process, whatever the material we have, in that it absorb or entrap the air, which is difficult to expel. That means whatever the particle, whatever the powder material we have, in that there might be the presence of air, or we can say there might be the chances of entrapment of air in our product, in our raw material powder, and they are very much difficult to remove. So what happens when we are spraying, or when we are adding such type of solid material into the water, when we are adding solid to the solvent, then at that time this solid, it will float. So solid will float, so they will not mix easily with the water, and due to that suspension cannot be prepared. So this floating phenomena, or we can say this due to the presence of air, this we can explain with the help of the contact angle. Here there is a contact angle in between the solid and the liquid, and due to that the material that floats. For example, if the contact angle that is 90, then material or the solid powder, it will float on the surface of the water. If contact angle that is 0, that means there is a complete wetting. That means completely powder, it will go into the solvent. That means inside the solvent it will go. That means complete wetting is there in between the solid and solvent. And if contact angle that is 180, then insignificant wetting. We can say, for example, sulfur and charcoal, they are such a substance which float on a water, or which have the contact angle of 90, whereas zinc oxide, it shows the complete wetting of the solid molecule. So always we need to improve the intimate contact of the solid with the water, and we should prepare one of the dispersion of the solids. So the dispersion of the solid in a vehicle, for example, we are taking the example of water, that can be achieved by two different methods, or we can say that two different approach. First one, we can go for a water miscible co-solvent. We can use the water miscible co-solvent to prepare the dispersion of solid. Another one, that is wetting agent. We can use the wetting agent, or we can add wetting agent. As a wetting agent, we can use the surfactant. We will see this. For example, first one, if we see the approach of water miscible co-solvent, then alcohol, glycerin, propylene glycol, these all are miscible with the water. So we can use such type of solvent for the preparation or for the wetting purpose. So here, if we are taking the example of glycerin, then during the mixing, glycerin, it forms one of the coat around the particles. So first, what we need to do, that we need to add our powder into the glycerin. We need to mix our powder with the glycerin. So there will be one of the coating will be formulated in surrounding area of the particle. Then now water that is miscible with the glycerin and water, they are mutually miscible to each other. So due to that, so it will wet the particles. So now whatever the particle we have, there is one of the coating of a glycerin, and we can add them into the water. So by this way, whatever the particle or whatever the powder that is not directly miscible to water, or it is not directly possible to incorporate into the water, but instead of that, what we can do, we can form one of the coating of glycerin, and then afterwards we can add into the water. Over here in the pictorial view, we can see the sequence of steps that is involved in the wetting process of solid by glycerin. See, first we have the glycerin, we have the solid substance particle we have. In between the particle, there is a voids, or there is an entrapment of air, and we should add first such a powder into the glycerin. So there will be the initial coating, and initial coating in a glycerin that will be it will be come inside the voids. Voids will be filled up by the glycerin. Then there will be the complete contact, and due to that, there will be the coating of the glycerin around the particles. Then afterwards, we should separate such a particle, and now the particles, they have been separated out, and then afterwards, see over here we can say there is one of the coating of the glycerin around the particles, and such a particle or such a powder, then afterwards we can mix or we can add directly into the water, and now they are easily miscible, or we can say miscible, or it will be easily wetted into our suspension or into our vehicle. So this is one of the approach that we can use to prepare the dispersion of the solid. See, water, they have miscibility with the glycerin, that's why this is possible, and same way we can use the alcohol also. So by this way we can prepare the dispersion of solid by using co-solvent. Then surfactant. Surfactant, what exactly the surfactant is doing? It reducing the interfacial tension in between the solid particle and the vehicle, so that the contact angle that will be lowered, and air, that whatever the air that is present in between the particle, that will be displaced from the surface of the solids, and due to that, the dispersion will be initiated. Here, as a surfactant, we should use the HLB range of 7 to 9. HLB, that is the hydrophilic lipophilic balance. On the basis of this HLB, we can decide the surfactant, or we can decide the surfactant that should be used as a wetting agent. So HLB range, which the surfactant which have the HLB range in between 7 to 9, that should be used as a wetting agent for dispersion of solid. So minimum amount of surfactant, here the precaution should be taken that minimum amount of the surfactant should be used for the dispersion of solid. Because with surfactant there is one of the issue that sometime in higher concentration it creates the foam. That means foams will be interrupted or forms that will be entered into our product. So it will not be easy to pour from the container. So always we should consider that if we are using surfactant for the preparation of any type of suspension, then the concentration, or we should consider that how much amount of surfactant or how much concentration should be added into our product. So by this way, again, we can prepare the dispersion of solid. Then structured vehicle deflocculated suspension. Here we are using the structured vehicle, and by that way we can prepare the deflocculated suspension. Now structured vehicle, they exhibit the pseudoplastic or plastic behavior, and also they exhibit thixotropic behavior. That means they follow non-Newtonian law, or we can, in another sense, we can say the substance which follow or which exhibit the pseudoplastic, plastic or thixotropic behavior. That means they do not obey the Newton's law of flow. That means such a liquid or such a substance, they are non-Newtonian fluid. Now, in non-Newtonian fluid, we can divide them into a plastic behavior, pseudoplastic behavior, and dilatant flow. So, in this condition, if we are using thixotropic behavior, then that can be used to prepare the deflocculated suspension. Here, thixotropic behavior, that means it has gel-sol-gel transformation. That means initially when we have prepared one of the product and afterwards we are keeping them into site. That means we are keeping them in a storage condition. So at that time it will be in a gel condition. That means particle, they do not settle in such a condition. Particle, they will not settle at the bottom. Then afterwards, when we are mixing, when we are shaking this bottle to remove the product. So especially in case of suspension, one of the instructions that is written on the product, that is shake well before use. So over here, if we are shaking it, so that gel, that will be converted into the solution form. That means it will come in a solution form, that so due to that it will be easily poured from the bottle or easily poured from the container to another container. Then afterwards again we are storing them, then it will be converted into a gel form. That means the thixotropic behavior, that is known as a gel-sol-gel. That means initially the product that will be in a gel condition, when we are not giving any type of force, when we are giving the force or we are giving shearing stress to this product, then it will be converted into a sol state, that means solution state. And again when we are storing it again, then it will be resettled as a gel form. So here the settling of the particle, that could be avoided in a gel form. So hard cake will not be formed over here. Here in this condition, we can, that's why we are using this thixotropic or this plastic or pseudoplastic behavior substance. That means we are using, that's why structured vehicle, to prepare a deflocculated suspension. And for that we can use hydrocolloid substance. So hydrocolloid, they have property that they are hydrated in a water. That means they will swell, and due to that the high viscosity will be obtained at low concentration. In our product, if we are using minute amount of hydrocolloid, then viscosity will be raised so that particle will not be settled down. Another thing we can say about the hydrocolloids, that they can act as a protective colloid and they stabilize the charge, and due to that they will reduce the repulsion in between the particle. So for that also we can use the hydrocolloids. Here non-ionic, ionic and clays, that is used as a hydrocolloid substance. For example, some non-ionic type methyl cellulose or hydroxypropyl methyl cellulose, and especially this non-ionic type that is used for the oral preparation. And if we are using or if we are preparing the oral suspension, then higher concentration of the non-ionic hydrocolloid will be required in our formulation. Then anionic type, sodium CMC, sodium carboxy methyl cellulose, or polyacrylic acid, that means carbopol, they are the anionic type of hydrocolloids. And third one, that is a clays. Bentonite they are using as a clays as a hydrocolloid. So over here, if we are using or if we are preparing the parental product, then the concentration of the such type of suspending agent or the hydrocolloid that is in between 0 or that is nearly 0.5% weight by volume. That means very small amount of concentration that is required in case of parental product. Whereas if you are using clays, for example bentonite, if we are using as a suspending agent, then they are effective in between the concentration of 2 to 5% weight by volume, and that depends on the pH of the system and ionic strength. Now if we are using clays as a suspending agent, then the care should be taken that always we need to add preservative into such type of product when we are using bentonite. See, because the bentonite or clays, especially we are considering about the clays, they promote the growth of mold. So always we need to add the preservative into our product, and as a preservative we can use methyl paraben or propyl paraben. So by this way, hydrocolloid, if we are using hydrocolloid, then we can prepare the deflocculated suspension. Then controlled flocculation, flocculated suspension. Here the flocculation, we need to achieve the flocculation. Now the flocculation that can be produced by addition of the flocculating agent. See, flocks, that means the aggregation of the particle, and to achieve such type of flocculation we need to add the flocculating agent. Here the electrolytes that can be act as a flocculating agent, then we can use the surfactants also, and we can use the polymers for a flocculating agent. We can use this all three kind of substance. We will see this one by one. To achieve flocculation, we can add the electrolyte with an opposite charge. If we are adding the electrolyte with an opposite charge, then intensity of charge it will be decreases. For example, if we have the molecule of the positive charge, and in this condition if we are adding another one substance or another negative charge electrolyte, then intensity of the charge it will be decreases, and due to that the zeta potential of the substance or of the liquid that will be decreases, and due to that attractive force that will be entered, or we can say it will be predominant in between the particles, so that the flux will be achieved in the suspension. And another approach we can say, we can use the surfactant and polymer which can act as an adsorbing agent and which promotes the flux. This substance they will form one of the bridge in between the solute and solvent, and by that they will initiate the flocculation in our product. So first one, electrolytes. For example, bismuth subnitrate. If you have prepared bismuth subnitrate that is dispersed in water, now the bismuth it have the positive charge. That means in between the substance, in between the particle of the bismuth, there will be the repulsive force. That means there is a presence of repulsive force in between the solute molecule. So due to that, particle will remain so far from each other, and due to that the deflocculated system will be observed in our product, in our final product. So now in such a condition, see over here the repulsion that is predominant, or we can say repulsion that is present in between the particle. In such a condition, if we want to initiate the flocculation, so in that condition we need to reduce the positive charge in between the particle, and for that we can use the flocculating agent. For example, one of the flocculating agent that is suitable for the bismuth subnitrate system, that is the monobasic potassium phosphate, that is added in a small quantity. Now here the negatively charged phosphate ion, they have the negative charge, and here the negatively charged phosphate that will be absorbed on a positive bismuth particle. So due to this, whatever the substance we have that was of positive charge, in that we have added the negatively charged particle. So due to this repulsion in between the particle, that will be decreases, and due to that we can, same way we can say the attraction in between the particle will be increases, and due to that the flux will be formed in our product. Now over here we have added very small quantity of negatively charged phosphate ion. Then afterwards, if we are adding more amount of the flocculating agent, for example, if we are adding more amount of monobasic potassium phosphate, see initially when we have only alone bismuth subnitrate, so at that time the zeta potential that was in a positive mode. Then afterwards, if we are adding more amount, small quantity we have added, so due to that the zeta potential will be reduced, zeta potential will be decreases, and then afterwards more addition of flocculating agent now we are adding, then zeta potential it will become 0. So due to that the attraction will be there in between the molecule. Now again on further addition, now again more amount of flocculating agent we are adding in our product, then negative charge will be predominant, or we can say negative charge molecule will be increases, so that zeta potential it will become negative. Again negative charge will be higher, so again there will be the repulsion in between the particle, or we can say the particle they will experience repulsive forces. So that always we need to consider the concentration of the electrolytes also. That means how much amount of the electrolyte that is required in our product, that is also important. See the phenomena we can say over here, if we are plotting one of the graph of zeta potential, this one is a zeta potential, this one we are raising the concentration of phosphate ion, and already we have the bismuth ion suspension we have. So over here initially when there is a presence of only bismuth ion, so due to that we can say the zeta potential that is on a positive side. See bismuth ion that is it have positive charge, that's why it is on a positive side. Then afterwards we have added the small amount of a phosphate ion, so that zeta potential will be reduced. So initially that was in a caking zone, then afterwards this will come into the non-caking zone, or zeta potential has been reduced. That means we can say the attraction has been induced, and due to that the flux will be formed. Again I repeat, the flux, that means the aggregation of the molecule. So over here the flux have been formed. So afterwards more and more amount of phosphate ion if we are adding, then zeta potential at one time zeta potential will be 0. Then again if we adding more amount of phosphate ion, then phosphate ion it has negative charge, so that zeta potential it will goes towards the negative side, and due to that again it will have the caking zone. Or in another sense we can say, if we are comparing this with the sedimentation value, then initially zeta potential was higher, and at that time whatever the product we have, it was in a caking zone. That means particles they act like a deflocculated suspension, and due to that the caking zone is present, or we can say the caking will be observed in our product, because the system that is in a deflocculated state. Then afterwards the attraction in between the particle have been raised, and in such a condition the particles or our suspension it will come from the caking zone to non-caking zone. That means the system that has been changed. Now over here the flux, that will amount of flux that is higher over here, so due to the higher density of the flux they will show the sedimentation, but they are easy to redisperse, so that's why they are converted into a non-caking zone. Then afterwards again the zeta potential, if it goes to the negative side, then again the sedimentation value that will be decreases. See over here we can say the sedimentation value it should be near to 1. If it is near to 1, then the stability of the product that is higher. Over here we can say it is towards the 0. Initially it was towards the 0, near to 0. That is not good for the preparation of suspension. So over here if the value of sedimentation volume that is near to 1, then it is good. So over here the suspension that is good, and due to the reason behind this, that is the presence of or the addition of the negatively charged molecule, and we have reduced the repulsion in between the particles. So that's why the suspension that has been improved in this condition. So electrolyte, it plays very important role meanwhile the formulation of the suspension. See, in this product, this figure also we can say initially we have uncoated particle, or that means we can say deflocculated system we have. Then there is the adsorption of negative charge. See here positive charge that is present, so that's why there will be the repulsion in between the particle. Then afterwards we have added the negative charge molecule, so there will be the adsorption of the negative charge on a positive charge. So that's why we can see in this figure there is a coated particle, and due to this the flocculation will be achieved. We can see here there is the aggregation of the particle because the charge has been nullified, or we can say the neutral charge that is present, and due to that there is no presence of repulsion, and due to that the flux that has been created in our product. The same way we can have one another example, positively charged flocculating agent, that can be, for example, aluminum chloride that can be added, and negatively charged suspended particles such as sulfamerazine. If we are formulating suspension of sulfamerazine, then in that condition, to reduce the charge, see this one is a negatively charged, and to reduce the charge we can add the positive charge molecule or positive charge flocculating agent such as aluminum chloride. Then another one approach is that is of surfactant. Surfactant, it improves the dispersion by reducing the interfacial tension. Again we are discussing this thing. It can act as a wetting agent and also as a deflocculating agent. For example, if we are using the ionic surfactant, then it will have one of the hydrophilic head and hydrophobic tail. So head, it will adsorb on a solid surface, and tail, it will form bridges in between the particle. The example we can say that is SLS, that means sodium lauryl sulfate, sodium dioctyl sulfosuccinate, and non-ionic surfactant that also used for the formulation of suspension, for example, twin. So by using surfactant, again we can say we can reduce the interfacial tension and we can have good product. Then polymer, they are acting as a flocculating agent because a part of polymer chain, it will adsorb on a solid surface with a projection. We can see in the figure, these are the polymer molecule. They can act as a projection onto the solid particles. That means it will be adsorbed on the solid particle. This round circle, that is a solid particle in which polymer has been adsorbed, and it will show one of the projection with the another particle also. So by this way we can say it can act as a flocculating agent and it promotes the flocculation in the suspension. For example, xanthan gum, ionic heteropolysaccharide that can be added to the sulfaguanidine suspension. So we can use the approach of polymer also. We can use over here the hydrophilic polymer also. The hydrophilic polymer, they form one of the sheaths around the particle and they can induce the flocculation. We can have one of the example in acidic solution, sodium sulfathiazole, it will be precipitated out with a negative charge. So sodium sulfathiazole, if we are adding into the acidic solution, it shows a precipitation, and such precipitation that will be of negative charge. So if in this condition, if we are adding gelatin, it has the positive charge, then it will form one of the coating around the negatively charged particle, and by that way we can initiate the flocculation. And such a product, whatever the product we will have, they will have less prone, or they will be less prone to cake formation. That means in such a condition cake will not be formed. See, always remember, cake is formed in case of deflocculated system, and if we are converting our system from deflocculated to flocculated, then in such a condition cake will not be formed. And cake, once the cake is formed, then it is very difficult to resuspend into the suspension. So that's why cake should not be formed in our product. Then flocculation in structured vehicle. Now the combination of two, the combination approach. We are considering, for example, if we are using flocculating agent, and by that way we can form the aggregates or aggregates of uniform size that can be promoted, and by that way the flocculation that is achieved in our product. But if we are initiating the flocculation in such a condition, supernatant layer that will remain the clear due to the presence of flocculating agent or due to the presence of flocks. The density of our flocks that will be raised, and by that way it shows the sedimentation. The another one approach, that is of structured vehicle. We have discussed this also, and structured vehicle, it prevents the aggregates from settling. So over here we need to use, or we need to initiate both the approach. So we can use the flocculating agent. Once we have prepared our product with the help of flocculating agent, then it will form the aggregates or it will form flocks. And another one, in same condition, in same suspension, if we are using a structured vehicle, then it will not allow such a flocks to settle. That means flocks will not be settled, and supernatant layer, it will remain as it is, and there will be the good stability in our product. So sometime it shows the incompatibility also. Such type of combination, it shows the incompatibility when hydrocolloid, that is of anionic, that is added to a cationic flocculating agent such as aluminium chloride. So sometime it shows the incompatibility also. So care should be taken meanwhile using the approaches of flocculating agent and structured vehicle together. We can see here in a figure, for example, if we have uncoated particle, they are positively charged, negatively charged and neutral. In this we are inducing the charge, we are using cationic adsorbent, and due to that the positive charge has been initiated over here and the particle, they have been coated. And in the same way we are inducing another charge also, anionic flocculation or anionic flocculant we are using, and due to that the flocculated particle have been observed in our product. That means flocculation also have been initiated over here. So we have used the two approach together. See over here in this figure we can see the suspension of the flocculated particles before adding suspending agent. In this condition we have one of the product, that is flocculated suspension, but here due to the presence of flocks, this product has been sedimented or supernatant layer that is very clear. And now in this condition, if we are adding the suspending agent, or we can say structured vehicle if we are using, then the finished product, it will look like this. That means the flocks or the aggregation, there will be the presence of aggregation and it will remain uniformly throughout the suspension. So this approach also, we can, by the use of this approach, we can have the good suspension with a good physical stability. So over here in this video we have discussed about the different approaches for the formulation of the suspension. First we have discussed about the dispersion of solid, then structured vehicle. For the deflocculated suspension we can use the structured vehicle. Then control flocculation, here purely we want to achieve the flocculated suspension. That means we can use the electrolyte, surfactant or polymer. And the third approach we have discussed, that is the flocculation in structured vehicle. That means the combination of structured vehicle and flocculated suspension. So here all three approach we have discussed in this video tutorial. Thank you very much for watching this video.